Hi guys, so I wanted to talk about covalent bonding in this video. And so covalent bonding from its name means that there's a sharing of valence electrons, right? And the reason why this happens is because two highly electronegative elements are trying to pull at each other's electrons, right? So covalent bonding happens between two highly electronegative elements. And if we look on the periodic table, right? Um, in on the periodic table, you'll notice that the highly electronegative elements, right? Remember, electronegativity grows going from um, left to right and then up, down to up, right? Electronegativity grows this way. If you'll notice all of the highly electronegative elements, well, they're going to be over here on the periodic table, and you'll notice that they are mostly non-metals. Okay. And so, if we look at the periodic table, we know that when two nonmetals participate in bonding, they'll most likely form a covalent bond. Okay? And so, when it comes to drawing the structure of these covalent bonds, we use a Lewis dot structure. And so, for example, if we wanted to draw the molecule F2, right, fluorine 2, well, fluorine has 7 valence electrons by itself. Fluorine, right, another 7. Well, if these two elements really would like 8 valence electrons, and so what they can do is share those 2 electrons, right? And the way we represent this isn't by putting 2 electrons and putting a circle here, right? We represent it using what's known as a stick. Okay, and so a stick will represent a covalent bond in our Lewis dot structure. Okay, now you might be wondering, well, how do I get that? How do I get that structure? Well, one of the ways we can do this is by using what's known as an EVO chart. Okay, an EVO chart. And EVO is short for element, valence electron, and octet. Right. It's just a way of keeping track of all of the valence electrons that are participating in bonding or not participating in bonding. Okay, so if we look at F2, right, we can look at the element and note that we have two fluorines. Okay, each fluorine has 7 valence electrons. How do I know it has 7 valence electrons? Well, on the periodic table, you have all of these groups, all of these families, right? And they are numbered as such. So all from 1 to 18. So if we look at the group numbers, um, we see that fluorine is in group 17, right? So when we're looking at covalent bonds, we're mostly going to be looking at nonmetals. And so we can just look at the very last number and we can know that that's how many valence electrons that element has. And so since fluorine is in group 17, we know that it has 7 valence electrons. Just a really quick shortcut there. To get to the octet, to get to 8 valence electrons, it's going to want to share one more. Okay? So it's going to try and share one electron with somebody else so that it can get to its octet. Okay. And so if we total that up, 2 times 7, right? 2 times 7 is 14. 2 times 1 is 2. All right. This 14 represents the total number of valence electrons. So total number of valence electrons. And I'll abbreviate that VE. This 2 here represents the total number of bonding electrons. So total bonding electrons. All right. So if we know how many total bonding electrons there are, that actually tells us the total number of covalent bonds. If we divide this number by 2, because there are 2 electrons per covalent bond, as you can see over here, that'll give you that there is 1 covalent bond in this molecule. Okay? So that's useful information, and we can always rely on that um, for our molecules, right? Since this is the total number of valence electrons, if we subtract off the number of bonding electrons, so 2 here, so that's the number of bonding electrons, and I'll abbreviate that, we get the number 12. And what this represents is the total number of non-bonding electrons. Okay, these are electrons, valence electrons on the elements that don't participate in bonding, right? So that gives us some useful information. We have one covalent bond and 12 non-bonding electrons, right? And so the way we can draw this is, well, in order to connect two elements, you of course need a covalent bond, and we're going to just stop right there because that's our one covalent bond. Okay. Around each element, there should be 8 valence electrons, right? That's the original purpose of bonding. So this fluorine only has 2 valence electrons around it, thanks to that bond. So we're going to give it 6 dots. Okay, that'll give it its 8. If we look at this fluorine over here, we'll give this 6 dots. And actually, if we count up the total number of dots, that's 2, 4, 6, 8, 10, 12 dots, the total number of non-bonding electrons, right? So we are pretty confident that that is indeed the structure. Okay, we'll do one more example. If we did O2, right, we can do our Evo chart element, valence electrons, and I'll abbreviate that VE, and octets, right? So we have 2 oxygens. Each oxygen, right? Oxygen is in group 16, so it has 6 valence electrons, and it needs 2 more to complete its octet. Okay, so we have 12 valence electrons in total and 4 bonding electrons, and I'll abbreviate that once again. This 4 can be divided by 2 to give you 2 covalent bonds, and I'll abbreviate that. This 12, you can subtract 4 from it, right, to give you 8 non-bonding electrons. Right? So we got to figure out, all right, the structure needs 2 covalent bonds, 8 non-bonding electrons. And so to connect the elements, well, if we put just one bond there, that's only one covalent bond. So we're going to put 2. In fact, this molecule has a double bond. And then to complete the octet on each oxygen, we're going to put 4 dots, 4 electrons, 4 non-bonding electrons on each oxygen. Okay? So that should serve as a good starting point for our molecules. Okay? Take care. Thank you.